everyone, welcome to BYJU'S Exam Prep and I am Vipin Kumar. Now in this session of Sunday Ka Funda, we bring different concepts. We try to explain it with experiments and try to basically make the concept simpler. Today, in this particular video, I am going to explain you the concept of thermal conductivity and thermal diffusivity by using this coffee cup. I have just poured hot coffee in this. It is very hot. Maybe you can see the vapors coming out. Okay, so I am going to explain and you are going to understand the concept of thermal conductivity and thermal diffusivity by using these three cups. Now what are these three cups? The first cup is steel cup. Okay, and I hope that you know the thermal conductivity of it. Thermal conductivity is around 15 watt per meter Kelvin. This is glass cup in which I have poured this hot coffee. Okay, this is glass cup and glass has a thermal conductivity of around 1.5 watt per meter Kelvin. So this steel cup has around 15 times higher thermal conductivity than this glass cup. Now the last cup is ceramic cup, okay, which we very often see in our homes more than glass cup and steel cup. Basically we drink tea and coffee usually in ceramic cup because it's comfortable. Why? We are going to understand. Okay, so this is ceramic cup and the thermal conductivity of ceramic is around 3.54 watt per meter Kelvin. So thermal conductivity of this ceramic cup compared to this glass cup is around 3.5 times more or 3 times more, whatever you want to call it, but basically it is more. Okay, now let us see what is the problem. So this is very hot coffee. This is very hot coffee. It's very hot outside. I don't want to wait very long. Okay, so I want to cool it faster. I want to drink it faster. So if I want to cool it faster, what can I do? I can increase. You see, look, this, you can see this coffee, right? You can see this coffee. Now the coffee is at higher temperature inside. Outside this cup, temperature is lower. Surrounding temperature, let us say some 30 degrees Celsius. Inside it is around 50-60 degrees Celsius. So convection is also happening. I am not talking about convection, but conduction, let us focus. From this wall of this coffee cup, of this glass cup, heat is getting transferred through this wall, glass cup wall, cylindrical wall. Okay, so conduction is happening from the coffee to the atmosphere through this wall, Now I want to drink it faster. What can I do? I can increase the thermal conductivity of this material. How? I can pour this coffee into this steel cup. Now this steel cup is having 15 times more thermal conductivity than this glass cup. So the heat transfer, conduction heat transfer from the steel wall will be much faster and I will be able to drink my coffee much faster. Okay, now in winters, what happens? You want to keep your coffee or your drink or your tea much warmer for a longer period. Yes, so you don't want to increase the heat transfer, you want to decrease the heat transfer. So what can you do? So you will simply say, sir, decrease the thermal conductivity. But you see, glass is already 1.5 watt per meter Kelvin. If you go to market and buy something with much lesser thermal conductivity, it will be expensive. So what can I do? Here you will introduce the concept of thermal diffusivity, which we are going to explain in some time. But if you see, usually if you transfer this coffee into the ceramic cup, then this ceramic cup is having the ability to store this heat for a longer period. Its heat capacity is more, we are going to understand that. But ceramic cup will be able to hold this drink, this coffee. It will keep the coffee warm for a longer period. even if its thermal conductivity is 3 times higher than this glass cup, its thermal conductivity is higher than this glass cup, how much? 3 times. Still, it will keep that coffee warmer for a longer period. Why? Because of the concept of thermal conductivity. So if you are able to understand this, let me explain it one more time. Then we will go to our lecture and we will see what is that, how is it happening. So again, coffee is in this cup. Coffee is in this cup. It is very hot. It's summer outside. I want to drink my coffee faster. What will I do? Increase the thermal conductivity. I will transfer it into steel cup. Its thermal conductivity is 15 times higher than this glass cup. So heat transfer due to conduction from this wall will be much faster. It will cool down faster. I can drink it faster. But let's say it's winter. It's winter and I want to keep my drink warmer for a longer period. What will I do? I cannot bring a material which has lesser thermal conductivity because it will be very expensive. It has already very low thermal conductivity. Then I will use my heat transfer concepts and I will see, array, this ceramic cup can keep my coffee much warmer for a longer period in winters. So I will buy this ceramic cup, I will pour my coffee in this cup and I will enjoy my drink for a warm drink for a much longer period. Now why is it happening? Let's go and see by heat transfer formulas. Okay? Chalo. Welcome back. And we were trying to understand the concept of thermal conductivity and thermal diffusivity by using 3 cups. Yes? Now let's not just talk in air. Let's talk about some numbers. Okay. So what we do is, let us take the same 3 cups. Here, this is steel cup. This is ceramic cup. And this is glass cup. And when we talk about numbers, what we need thermal conductivity, density, specific heat, and heat capacity. So heat capacity is basically the product of these two. And thermal diffusivity. So thermal diffusivity is defined as K upon rho Cp. So this is basically your heat capacity. The ability to store heat, to hold heat. Okay. Now let's see. I told you that I have coffee in this glass cup. Yes. But I want to drink it faster. I want to drink it faster. So some heat conduction that is happening here, I want to increase. So what I do? This is my thermal conductivity. I take a cup which has higher thermal conductivity. So I'll go to steel cup and I'll take, you see, steel cup thermal conductivity is around 14 to 15 times higher than glass cup. So this will increase. More heat conduction will happen and coffee will cool down faster and you can drink it. But what happens when you want to decrease the heat transfer so that the coffee will be warmer for longer period in winters usually? So go and buy a cup that has lower thermal conductivity compared to glass, but that will be insulating material. It will be very expensive. Usually we don't buy that. What we do? We use a ceramic cup. And if you see here, ceramic cup thermal conductivity is higher. That means heat transfer will be higher. That means the coffee will cool down faster. But that does not happen. Why? Because here, this also plays a role. This also plays a role. Okay, which is called as heat capacity, the ability to store more heat. So if you multiply density and specific heat, so you see it is 2800 for steel and 5100 maximum for ceramic and lowest for glass. But when we take this ratio, alpha is minimum in steel and it is maximum in ceramic. So what does it mean? If thermal diffusivity is higher, if alpha is higher, that means this is higher and this is lower. So it is conducting heat fast and it is not able to store it. So that is why when you hold a steel cup, you feel very uncomfortable because a lot of heat is coming through it. And also it is distributed very fast. So if alpha is higher means heat distribution is faster. Heat distribution is faster. But here you see it is minimum. So as I said, in ceramic, what is happening? This is maximum. This is maximum. So alpha is equals to K upon rho Cv. That means this is higher, yes, but this is much lower. That means alpha is low. What does it mean? When it is maximum, when heat capacity is maximum, that means that ceramic cup is able to store more heat. It is not allowing it to go outside. It is just, it is not distributing it in the whole cup. It is just storing it. And if it is storing it, coffee and the body, ceramic body will come in thermal, I mean, it will not come in thermal equilibrium, but they will try to come in thermal equilibrium. Their temperature difference will be much lower. If temperature difference will be much lower, heat conduction will be much lower. Heat conduction will be much lower. You will be able to store that coffee for a longer period and it will keep warm. It will keep warm. Okay. So I hope the concept of thermal conductivity and because a lot of people remain confused between what is the difference, physical difference between thermal conductivity and thermal diffusivity. So you have to understand that thermal diffusivity also plays a role in heat transfer. Okay. So the combination of thermal conductivity and heat capacity will define thermal diffusivity. Okay. So I hope it is understandable. This concept is crystal clear. Okay. Chalo. So keep watching these sessions for more interesting concepts. Okay. Chalo. Thank you so much. Thank you so much.